place that you come to develop cutting-edge biomedical technologies to manage health conditions. We create computational models of people's neuromusculoskeletal system, and then we apply that to design surgeries for paediatric conditions like cerebral palsy and alike. Better design of surgeries, design, printing of implants, printing of the surgical instrumentation, through to neurorehabilitation, where we be a one-stop shop.
To my knowledge, this is the world's first. So we're integrating all these different therapies that have shown to be promising in spinal cord injury, and we're making it better. These kind of thought-activated therapies with pharmacology and electrical stimulation, we have evidence that it works.
The idea is the one of neuroplasticity. We know that we can remap our nervous system. We have a rehabilitation device, and we are using a brain-computer interface. We are interpreting that data using artificial intelligence. That thought is then sent to a digital twin of the person. What happens is that the digital twin controls the rehabilitation device. The person is more empowered, feels that the rehabilitation, has control over the rehabilitation, and understand there is that missing connection is being re-established between the movement that you're doing and actually perceiving it.
So in 5 years, I really hope to have a working therapy, and maybe in 5 years I'll be standing up talking to you about this.
10% or so of all wrist injuries have this ligament injury. It affects young people. We're talking about a young active person who's working independently in his 20s, starts to get pain, and by mid-30s they start to lose function. So what we're trying to recreate is a ligament scaffold that is customized to the patient, that is seeded with cells, so it's like a live ligament that's ready to grow and heal.
So we're able to print what we call a hard soft print, which is more able to accurately represent bone mixed with cartilage and how they move. When you get it right, it's euphoric.
This is definitely a flagship project. So what we would like to be able to do is, for any type of clinical problem, have a digital representation of the individual who has that affliction. And so that means we can represent their anatomy, their mechanics, and even their tissue biology, so that when we're designing a therapy, we're not guessing. We can predict what that should be, and then we can precision design or manufacture that product.
If we get all these disciplines together and create this platform, it could make a big change in sports injuries and orthopedics. The great thing about the Gold Coast and this Health and Knowledge Precinct is the proximity of all the different teams. So we've got this combination of everything in one place, which I'm not so sure is replicated anywhere else.
So you get the right people jammed into a close space and they'll produce creative things.
I don't know how I got so lucky. How lucky am I to be in this place in this time, in this institution, in this city? It's just, it's fate.
We don't get this very tight location, and the passion to actually collaborate as a group of completely different disciplines. It's really just the step change, it's disruption for the health industry.